Well, hello, this is Rich from insideHPC. I'm here with Dan Stanzione from TACC, the Texas Advanced Computing Center. Dan, thanks for joining me today.
Good morning, Rich. It's good to talk to you.
Well, thanks for joining, Dan. A lot going on, I'm sure, with this COVID and this pandemic going on, but I thought we should jump into it. How is this pandemic affecting how people are doing research, and how is it affecting TACC?
We've changed a lot of what we do to deal with the pandemic. There's the basic operational things of shifting most everybody to working from home, and with the exception of a few people who really need to actually touch the systems to do maintenance on them at the office. But the bigger change has been prioritizing the work that we do to respond to the coronavirus. We have more than 20 projects involving, at this point, I think a couple of hundred researchers around the country and around the world, interacting with the center in various different ways to attack the virus, from just getting computation from us to help with software and data and distribution. We've retasked a substantial part of the staff and a substantial part of the systems to respond to this.
Well, Dan, the way I understand life science is very data intensive, and it seems like you guys are really, at least architecturally, with your supercomputers, you're well geared for this kind of problem, are you not?
I think we are. There's various different ways people attack it, and there's different kinds of both hardware and software approaches. I try and sort of class the work that we're doing as things that sort of relate to the people and social impacts, which is measuring the social distancing, doing the epidemiology, measuring who's in contact with who. There's the sort of genomic level of response, looking at host response, looking at the virus RNA sequences to figuring out, what it has in common with other viruses. And then there's sort of the molecular and atomic level, right, where we're looking at the actual structure and seeing what chemicals can bond with that structure and doing the drug screening and the vaccine design, upstream computational docking and folding for vaccine design. And all of those are sort of different in computational intensity and different in the kind of data that you need. So we find that we're using almost every different kind of system that we have here is employed one way or another.
Well, Dan, you've got these terrific resources for Exceed and NSF. I read that a lot of research in other areas has been put to a stop. Have you seen that? Have you seen a shift outside and people using TACC?
I don't think it's been put to a stop. We know it hasn't. Things have maybe slowed down a bit. We both have the issue of a lot of labs are physically shut down that we work with, and people are dispersed. But the computational work goes on. We haven't, with the exception of one day on the big systems where we stopped to do just COVID runs on Frontera, we've been prioritizing these runs on all our systems, but they still don't use all of our capacity. So the other things they're seeing a little more wait time in the queues, because when a big COVID job comes in, it goes first. But plenty of other jobs are still getting through. So,
Well, great. Well, hey, Dan, I want to thank you for coming on. So thanks again.
thanks very much, Rich. Thanks for having me. It's great to talk to you.